Hello everybody, I'm Nick, and in this video I'm going to show you how you can use ASP.NET Core and MediatR to create elegant and clean message processing services. Now, just to understand exactly what those services are, imagine you want to consume things like messages from a message bus or a queue, so things like RabbitMQ, AWS SQS, or Azure Service Bus, but also events that are streamed to you, so things like Kafka, Kinesis, or whatever Azure has. I think it's event hubs. So that is the main idea. We have some service with some sort of message or event, and we're consuming that. Now, in this video, I'm going to be using AWS SQS for this, but this technique can be adapted to any other service. And also, this video is sponsored by AWS, so if you want to get $25 worth of free credits for AWS, then you can find the instructions in the description down below. Anything we're gonna see here is absolutely free forever, so you don't have to worry about that. But if you want extra credits, then you can email them. And on top of that, I have a completely free course at nickchapsas.com on AWS and getting started with AWS as a C# developer, so you can check that out as well if you want to. If you like a lot of content and you want to see more, make sure you subscribe, ring the same notification bell, and for more training, check out nickchapsas.com. Alright, so before I just go and create queues and write the code, I want to just quickly visualize what you're going to be seeing. Now, I have a video talking about queues already in the channel, and you can check that, both traditional queues and pub/sub. But here, just to give you a quick introduction to the concept, what you have here is some sort of service. So let's say you have an API or some other form of service, and then user interacts with API. If this API needs to do things like call a database, or also send an email to a user to confirm registration and things like this, then you have usually two types of actions. You have synchronous actions that have to happen for this request to be a success, but you also have asynchronous access that don't really have to happen on that spot for this request to be a success. It can happen a minute later or 20 seconds later, and that's going to be absolutely fine. So the way we solve that problem is the following. We still have this API over here, and we still have a user interacting with it, but now only the necessary stuff that needs to happen synchronously happens synchronously. And then instead of doing every other asynchronous thing synchronously, we have what is called a queue or a message bus over here, or you can have a topic if you're doing pub/sub as well, and we're pushing that information as a message here. And then you have some other service, the consumer service, and that can be, for example, the emailing service, that will eventually take that message, consume it, and then send that email. That is the main idea. And there's many benefits in this, from resilience to processing to load leveling to other stuff I've talked about in that other video. But just to get the main idea, this is why you might want to use something like this. But how do you build a consumer? Well, let's take a look at the code. So what I have here for you is actually two projects. The first one is the API project. This one will be adding to a database and also publishing that message into the queue after we make any action. And this will be our consumer. The only thing I've done is I've added some messages, and those are our message contracts, the things that the API will be publishing and the consumer will be consuming. So created event of a customer, deleted event of a customer, and updated event of a customer. And then I have some very basic registration. Like I said, I'm going to be using AWS SQS. So I've already registered this in DI to use later in the consumer. Now, just because I don't have that already, I'm going to show you how easy it is to create a queue in SQS. So we're going to go into the AWS console and say simple queue service or SQS, and then say create a queue. We're going to create a standard queue. I'm going to call that customers. I'm not really going to change any of the default settings. We have encryption at rest by default. Some other stuff here. We don't need a dead letter queue, so I'm just going to go ahead and create it. And now we have the queue ready to send and receive messages, as you can see over here. Now, let me just quickly run the API and show you what the user would be seeing using this API and what you can do with it. So here in Postman, I have the requests. So what I can pass down is a full name, an email, a GitHub username that needs to be valid, and a date of birth. Everything here has validation. So if I try to pass down an email that is not an email, I'm going to get an email, it's not a valid email, and so on. So it is a real application. And by the way, if you want the source code, it is free for everyone because AWS has sponsored this video. So it's going to be in the description. And if I send this request, then I create this user. Now, this didn't just create the user in the database, it also published that message into the customer's queue. I'm going to go back to SQS and say send and receive messages. And I'm going to go to the bottom and say poll for messages. So receive messages. I'm going to stop polling because we already have one of them. This one. And as you can see, this has the ID, the GitHub username, the full name, the email, and the date of birth. all the information that the consuming service might need to take and then do something with it, whether that is send an email, do some email marketing, use it for analytics, everything you might be interested in doing with the user details and the fact that this is a created event, you can do like this. Another thing that's very important about this message is that as publishers, we also pass down in the message attributes what is the message type. And in this case, the message type is customer created. So whoever is consuming it knows that this is the customer created type. This is a very common practice because many services are filtering on those attributes. AWS also supports filtering on the body as long as it is a valid JSON object, which it doesn't have to be, but it almost always is. But attributes is also more efficient because you don't have to pass any JSON on the cloud. So this is a very good practice to publish the message type as you're publishing your message into a queue, or the event type when you're publishing it into an event log. But how do we consume this in ASP.NET Core? Well, the process is actually pretty simple. My recommendation is to actually create a new web app. And as you can see here, this is a web project, but remove all the controllers, all the endpoints, all that. The reason why I recommend this is because when you have services like this, you usually expose endpoints such as metrics and health. So you're going to have an API anyway, and you get the added benefit of being able to say the following. We're using the web application host, which you can see here. So this is the new abstraction in .NET 6. And if we want to consume with a long-running consumer using this service, all we need to say is queue consumer service over here. And we're going to make this extend the type background service. So this says implement the one missing member, which is the execute async. And now we sort of have this background service, which we can run in our application as long as we go into our DI and say builder.services.add hosted service and pass down the queue consumer service. And we also have a stopping token or a cancellation token. So if we want to cancel the processing, we can. Usually what you end up having is a while loop and say, if cancellation token is not cancellation requested, then in this case, just await for a second, and this will keep running in the background. I'm going to just turn this into an async task, and I'm going to pass down cancellation token, and that's it. We can have all the processing logic here. Now I'm not going to bore you with the AWS SQS specific implementation. I'm going to show you just how to do it very quickly. We need two main things passed down here, the Amazon SQS interface and then the queue settings to get the queue name. I'm just going to initialize all the fields in the constructor over here. And then in the execute async, outside of the loop, I'm going to initialize the object that says, I want some messages back from the queue. To do that, first we need the queue URL, and I can get that very quickly by just saying SQS get queue URL and passing down the queue name, which is in my settings over here. So queue name customers, which matches what we're publishing and what we created. And then we need to have the receive message request. So what this object does is it says, I want to receive some messages from the queue with this URL. I want to receive all the system related attributes of that message and also all the message specific attributes. So that message type that we pass down, that is a message attribute, very important. And then you can have a max number of messages you receive per receive request. Here I just say 10. Also, I should point out that 10 is the max. And now processing looks something like this. We have the receive message async call using the SQS client that sends that request object. We pass the stopping token or the cancellation token. We have a response, and the response has messages. So you loop around the messages, and once you're done processing them, you delete them. I'm going to just quickly replace this message to message.body, which is just a string. And I'm going to say console.write line and just write it and then delete it. So if I just run this service, since we have one message, we're going to process it, print it in the console and delete it. Let's go ahead and run the consumer. And as you can see in the console, we have it here. Now this is running, and I can go to the API and I can run the API too. And if I go to Postman and I create another user, again, this will now be processed in the consumer again. So we have this long running consumer now that just receives messages, and the messages have the body and then the message attributes, receipt handle, and a bunch of other stuff. Now, I generally like to show naive or bad approaches when I show best practices, just so people can understand where I'm coming from and why I choose to do things the way I do them. So a very naive way you might go about doing something like this is use a switch and say switch on message.message message attributes, and I'm gonna get the message type attribute, and that looks something like this. So switch on that message type value and have your cases. So case, and you can have name of customer created and break, and have your customer created logic here. So do this and then do that for all the other types you have. And if you're not interested in one, you can just skip it, but you have updated and you have deleted. And you know what? This is fine on the surface level, but this violates a few things. First, this method now knows way too much. It knows how to process every message type. So you might say, well, I'm going to create a customer created handler, and I'm going to say here, new customer created handler, and I'm going to pass that down there. But then what if the handler itself needs some services injected? Well, you might say I'm going to inject them in the constructor here, and I'm going to pass them down. But that is problematic too, because now those services are singletons, because this service over here is also a singleton. So there are many loopholes with this approach. You should not be processing messages like that. The completely other side of the story that I've usually seen is people trying to hand roll their own sort of messaging strategy pattern to fan out messages to different handlers. And I've been actually guilty of doing that as well in the past. But what I've come to understand is that message processing has so many things like latency involved and so many failure states that can cause performance issues that the performance benefit of hand-rolling your own version is actually completely load leveled and eliminated in the real world. So don't try to reinvent the wheel. And for that reason, I'm going to use MediatR to process messages. It's actually going to end up being a very nice and clean approach. Now, many people don't like MediatR, or many people exclusively use it for CQRS. That's not really what it was made to do. If anything, this is what it was made to do. So this is a prime use case for MediatR. Now let's see how I can introduce it here. What I'm going to do is I'm going to go to NuGet and I'm going to search for MediatR, but I'm going to try to use the mediator.extensions.microsoft.dependency injection. That already refers to MediatR, and it also adds the necessary DI extension methods to register MediatR. So over here, to register it, all I'm going to say is services.add MediatR, type of program, and that is it. That's my assembly marker. And now all of my MediatR related services will be automatically registered in DI. Now, how do I get a string message and convert it to a type and then pass the type to MediatR? Because MediatR effectively has requests and handlers in its basic request and response approach anyway. Well, it's actually pretty simple, but we do need to change a few things. Well, the first thing I do is actually create a directory called handlers. And here I'm going to put all the handlers for the messages I want to process. The good thing about this is that as opposed to this version where when a new message is being added, I need to go ahead and add a new case violating open closed, with this approach, all I'm going to need to do is create a new handler. It is way cleaner. Also, if I'm not interested in an event for some reason, I just don't have a handler for it, and I'm done. Now, you can also have server-side filtering, so tell the queue or the topic to never actually send that message in the first place, but it's worth pointing out that you can do that in your application as well in a very nice and solid way. So I'm going to go ahead and create my handlers. I'm going to create my customer created handler, and I'm going to do the same with the rest. So customer updated and customer deleted. All right, all my handlers are in place. Now, just existing isn't enough. I actually need to go here and say that they implement the request handler type, but that handler type requires a generic type parameter. And in this case, it is the request type. Now, the request type will actually simply be the message. The problem is that for something to be acceptable here, it needs to implement the iRequest interface. And since that doesn't return anything, it's going to be the iRequest version without any generic parameter. And this would be enough. As you can see now, this doesn't complain. The only reason why it complains is because I'm not implementing the missing members, which is the handle method over here. And we could just go here and leave this as it is, but it is not uncommon for messages to need to implement some form of interface or class, which contains some shared data sometimes. What I'm going to do is actually create an ISQS message interface, and then this should be an interface on the class, and now that should be the iRequest over here. And now all the other stuff should implement ISQS message, which still makes this work absolutely fine. So I'm going to go to all the other types and I'm going to say iRequest handler, customer updated. And of course, this also has to implement ISQS message. and the same for deleted. So we're gonna go quickly and just implement the missing members in all of them. And now the great thing about MediatR is that it actually just takes care of DI automatically. So if I wanna say inject a private read-only iLogger of type customer created handler and then generate the constructor for that, then I can go here and say logger.log information and say request dot, I don't know, full name over here. And I'm gonna just return unit.task back. And that is it. If I want to have async stuff, I could just turn this into async and await stuff. In this case, I don't really have anything. Now I'm gonna go and add similar logging logic in all of the other handlers, just so I'm able to differentiate between which one is being called. So I'm gonna say private read-only iLogger of customer updated handler over here. So logger, inject that, and then logger.log information request dot full name again. We're gonna see which handler it is by the message in the log message. So I'm just gonna say return unit.task, and the same thing for delete handler. But in this case, because we don't really have a full name, I'm just gonna return the customer deleted ID. Here we go. And now I have my handlers and my messages, but how do I go from just a string representation of the message to that type that is being sent to MediatR? Well, it's actually pretty simple. Let's just delete all that. We're not gonna use that bad code anymore. And again, the first thing we need is actually the message type. In the same way, I'm going to say message type equals message attributes, and get it by name. So message type over here. Now, this is a bit of a magic string, so it might be good to just extract it into a constant and just reuse it everywhere. Now, the main thing I need to do is actually take this information, the message type name, and convert that into a runtime type. So I'm gonna say var type equals, I'm gonna say type dot get type, and now I need to pass a string locating that type into my project. To do that, I'm gonna find the namespace, which is this one over here. So I'm just gonna say this dot, and then use that message type. And now I'm gonna load that time based on its location, based on its fully qualified name. Some people think doing something like this is a bad practice. It is not. It is absolutely fine. Now, this type can be null. So if the type is null, then you wanna log it and move forward. To log it, we're gonna inject a logger over here. So I'm just gonna copy that and say iLogger, here we go. And then in here say log warning, unknown message type, and then log the message type. And here I'm gonna say continue. The reason why I'm gonna say continue and not let it just be deleted at the end of processing is because this might be a new type and I might not wanna lose it because I just haven't implemented that handler yet. So it's gonna go here, it's gonna get retried a few times, and then it will be pushed into a dead letter queue. Now, this behavior does vary depending on whether you're using a first in, first out queue, or a standard queue, which ordering isn't really guaranteed, or an event stream or event log, where you might not be able to process any further if you don't process this message. So it really depends on your use case. For what I'm using, this is acceptable. What you could also do is actually use SQS to publish into the dead letter queue automatically, and then just delete it from the main queue without having to retry it more times. And now that I have that, I can actually get the typed message. So we're gonna say JSON serializer.deserialize, and I'm gonna pass down the message. Whoops, you can't see anything here. I'm gonna pass down the message body, which is the raw string. And as the second type, since I can't really use the generic parameter over here because I don't have it at compile time, I'm just gonna say type over here. Now, this means that var is actually object, which isn't great. So what I'm going to do instead, just because I now have that interface, is say that this is an SQS message. And yes, this is not null at this point, guaranteed. And now that I have the SQS message, which is also a request, I can send it to MediatR. So I'm gonna go all the way up here again and say private read-only iMediatR. And I'm gonna inject the MediatR interface over here. And then I'm gonna have a try catch because things can fail during MediatR processing. So try catch over here. And in the try, I'm just gonna say await MediatR.send. And I'm gonna send the typed message, and I'm gonna pass down the cancellation token as well to do things properly. In this case, the response doesn't matter, so I'm not gonna do anything with it. And if something does go wrong here, I actually want to log it. So I'm gonna say exception message failed during processing, and I'm not gonna throw because I don't want the service to stop. what I'm going to do is say continue. This will put the message into a retry loop, and it's going to be retried a few times before it's pushed into the delivery queue. The reason why I do that is because whatever fails in here might be transient, meaning it failed now, but if I try it again once more or twice more, it might work. So for that, I'm just going to say continue and let it be reprocessed in the next receive request. And now with all that in place, watch what happens. I'm going to go ahead and just run the consumer over here, and I'm going to run the API as well. So I'm going to go back here and I'm going to create a new customer. Here we go, customer create. I'm going to just copy the ID. And as you can see, this customer has been processed by the customer created handler, meaning it did go into that created handler. And just to see the flow, I'm going to just put a breakpoint here, and I'm going to put a breakpoint into the consumer as well. So that is going to be into this loop, and I'm going to go and just quickly send a request. Here we go. So what is going to happen? Oh, I am not debugging. So let me just quickly stop this service and debug instead. Here we go. So now I'm debugging. I'm going to create a customer, and customer is created. And as you can see, I'm going to get a response back. This response does have one message in it. Here we go. This is the customer created request. So I'm going to go in the loop. I'm going to get the message type. So it's customer created from that message attribute. Then I'm going to get the type based on its location. And as you can see, this is a runtime type. Then I'm going to check if it's null. If it's not, serialize it. I have the type message, customer created exactly as I wanted. Perfect. And then it's sent into MediatR. It goes into the appropriate handler with dependency injection. And then I can do whatever I want here in a very nice, open, closed, and single responsibility way. Very, very awesome type of processing. Of course, if I wanted to use the same ID to do something like an update. So if I go here and say your name now is Tom Chapsas, then as you can see, customer updated over here, Tom Chapsas, and so on. So if I go and I just delete that user with that ID, I'm going to see delete handler, the ID. So everything works exactly as you want it to. Now I want to add one more thing, because when you're processing messages, you have a fundamental difference between that and something like handling an API request. Because when you process messages, you don't really have a scope. But what if you have scoped services? Well, if you do have scoped services, then all of them go out of the window, because now you're effectively in a singleton in that consumer service, and each handler by default is actually transient. Same goes with the iMediator interface. However, here it is actually captured as a singleton again. So what if you want to have a scope for your message processing and you want that scope to be specific to each message? Well, you can actually do that. Now, to make this work, you actually shouldn't inject iMediator in here at all. So I'm going to go ahead and just completely remove it. And instead, I'm going to inject a private read-only iService scope factory. And this scope factory now can be used to create a scope. And now I'm going to go down here, and there's a few places where I can create my scope, but basically you choose, okay, what is in scope? Is this in scope? Then okay. Is just this in scope? Then okay, you get to choose that. Now, if you have things in the exception handler here that you also need to resolve a scope dependent service, then you might want to put it outside of this. But in this example, my scope will be this over here. So what I'm going to say is using var scope equals service scope factory dot create scope, and then I'm gonna say MediatR equals scope dot service provider dot get required service, and I'm gonna say give me the iMediator, and I'm gonna use that here. And now the scope is this, and outside of this the scope doesn't exist. So it's a new scope per message processed and then sent to MediatR. All the other services will be resolved correctly. Also, if you want to be explicit about your scope, you might want to use the old-fashioned way of doing things. So something like this, and now you can see that the scope is actually in here, but you don't have to. I prefer this syntax because it's just simpler. Now, iMediator by default is actually transient, and the handlers themselves by default are also transient. However, everything resolved in that scope will be maintained. And just to quickly demonstrate that, I'm going to go ahead and create a new service, and I'm going to call it GUID service. And all it's going to have is a GUID over here, so ID, and it's going to have a default value of GUID.newGUID. And that is it. I'm going to go ahead and register it as a scoped service, so services.add scoped GUID service, and I'm going to inject it into the handler. So I'm going to say, for example, created private read-only GUID service here, and have it be injected and logged. So logger.log information, and then GUID service ID to string, but I'm actually also going to create a second fake dependency that also injects that just to demonstrate it. So I'm going to say GUID class fake service, and that service will inject a private read-only GUID service over here. And that will also be able to return the GUID, but this one is actually coming from the GUID service. So I'm going to say ID over here, and I'm going to inject that. So private read-only fake service, and that's also going to be scoped. So I'm going to just duplicate this one over here. I'm going to go and register it. So add fake service as scoped. I'm going to go ahead and just run both the API and the consumer. I'm going to go ahead and create a new customer, and we should see the same ID within each request or each message. So I'm going to say create customer, go here, run this. And as you can see in the consumer, same ID for those messages, even though those are different services. I'm going to do it again, and it's going to be a new ID every single time. So DC5, and then 405. Here we go. So now you can have a scope in here. Just to demonstrate the difference again, just so you can actually visualize it and see it, if I did not use a scope over here, so mediator did not exist and it was coming from something injected from the service. So just quickly stop this over here and say private read-only mediator and inject it, and then rerun the consumer. Here we go. Then if I did the exact same thing, as you can see, I'm getting an error saying that cannot resolve the handler because the root provider is not scoped, but you say that these services are scoped. So what am I supposed to do? So you'd have to go with like transient over here. And if you do use transient, then you basically just lose the benefit of having a scope that is based on what you need. So we're going to just quickly run this just to show you the difference. So it got processed, but the IDs are different. So BB7E2, BB5AC, and then A6C2, D7F6. So as you can see, there's a difference in scope. I'm going to go ahead and just revert this change in case you want to grab this code and use it for your own project. So I'm just going to go ahead and delete all the fake stuff and revert everything to exactly as it was. So now every time you want to process a new message, all you need to do is create a handler for it. If you want to delete the handler, if you want to stop processing one, then just delete the handler, and that is it. And you also have an explicit scope. So everything very, very clear and very, very nice. You don't have to touch this code again unless you want to add some resilience on top of it. Another thing I want to mention, just because we have Mediator, is that you can actually use Mediator pipelines to add validation for those messages before they even get into this main handle method. So that's another benefit you can have. But I want to know from you, what do you think about this approach? And did you know about all these nice tricks you can do to manipulate the scope to something that you need? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making videos possible. If you want to support me as well, you can find the link in the description down below. Leave a like if you like this video, subscribe more to like this and the bell as well. And I'll see you in the next video. Keep coding.